Hi everyone, welcome back to my channel. We all know Marie Curie, right? The first woman to win a Nobel Prize and the first person to win the prize twice, which I did not know that, and low-key discovered polonium and radium, and from discovering that helped the research on radioactivity and cancer treatments. You know her, right? Well, did you know that she basically had an assistant with the study of polonium? Her name is Ștefania Mărăcineanu. Let's get started. Goodbye, Russell Wilson. Ștefania Mărăcineanu was born on June 18, 1882 in Bucharest in present-day Romania. Bucharest is the capital city of Romania and is the largest city, and interestingly, with its metro area population being 1.76 million, that makes it the 8th most populous city in the European Union. And with that out of the way real quick, since her name is Ștefania, I am not going to be able to say that correctly the entire time, so I'm going to call her Stephanie. And I think this is the first time we're in Romania. Hey, I need to put, whoa. Like, I'm thinking to have like a map, and each place we go to, like each country, each state, each province or whatever, we like color it in so that we could go all over the world somewhere. That'd be cool. I'm gonna think about that. She was the daughter of Sebastian and Sevastina, who were both 20 when she was born. Very little is known about her childhood, but what we do know is that it was bleak. We'll put it that way. Jumping ahead, she graduated at the Central School for Girls in her hometown. This school taught preschooling, primary, middle, and high school students. In 1907, she enrolled at the University of Bucharest. It is the oldest university in Romania, having been founded in 1864. 159 years ago. It has study programs in Romanian and English, has 19 faculties, and covers various fields in science, theology, humanities, and social sciences. Stephanie graduated in 1910 with a degree in physical and chemical sciences. Her graduating thesis was titled Light Interference and its Application to Wavelength Measurement. After she graduated, she began a career in teaching and taught in high schools in her hometown of Bucharest, also in Ploiești, Cumpălung, and Iași. I think I said this correctly. Awesomely, she got a position at her former high school, Central School for Girls, in 1915, and she would hold this position till 1940. After the fun times of World War I, and with the support of historian, educator, and zoologist Constantine Tirigescu, Stephanie received a fellowship from the Romanian Ministry of Science, and this allowed her to travel to Paris to further her studies. In 1919, she took a course at Sorbonne University in Paris. This school's history goes back to the Middle Ages, having been founded in 1257. The course she took was on radioactivity, and the woman teaching it was Marie Curie. Now, some historical context. Radioactivity was discovered in 1896 by Henry Becquerel and Marie Curie. Now, I'm not going to explain how radioactivity works because we're already going to be talking about science and radium and chemistry, but there are some interesting things found during its discovery that are relevant to Stephanie's story. How radioactivity was discovered was while Marie and Henry were working with phosphorescent materials, basically the chemicals that make things glow in the dark. When Henry wrapped a photographic plate in black paper and placed uranium salt on it, radioactivity was discovered. Now that's criminally basic, but that's as simple as I could get it. Now this new kind of radiation was familiar to the newly discovered X-ray radiation, known as Röntgen radiation, named after German scientist Wilhelm Conrad Röntgen, who discovered it in 1895. Further research done by many other scientists, including Marie and her husband Pierre Curie, showed that this form of radioactivity was a lot more complicated. Basically, and when I say basically, I mean basically, Ernest Rutherford specifically found that the elements of decay were more severe. When it comes to Mary and Perry's study of radioactivity, they expanded the research done by Henry, and from that, they discovered polonium and radium, and together, they coined the term radioactivity. This word defined the emissions of ionizing radiation, this includes nuclear radiation, by some heavy metals like lead and uranium. With their research on penetrating rays and radium, it launched the era of using radium for cancer treatment and could be seen as the first peaceful use of nuclear energy and the start of the modern age of nuclear medicine. So by the beginning of the 1920s, the phenomenon of radioactivity was in its heyday. Where Stephanie comes in is after the course at Sorbonne University, Stephanie pursued research with Murray in her library at the Radium Institute in Paris, now known as the Curie Institute. She would stay at this institute till 1926. At this time, the institute was becoming the center for study of radioactivity and radium worldwide under the direction of Mary. While here, Stephanie began working on her Ph.D. thesis on polonium. This element was already discovered by Mary, but she did research on its half-life. So what is polonium and a half-life? This was the one time I was like, why do I have to dig deep? I did not do well in chemistry. That was just a mess. Very basically, polonium is a chemical element, 84Po on the periodic table. This is a rare and highly radioactive metal, and half-life is the time it takes for the total amount of atoms, survival, to die out. The term is commonly used in nuclear physics to describe how fast unstable atoms undergo radioactive decay, which is what Henry and Mary discovered. Think about it like this. The human body is made of atoms, and a full human life is 80 to 90 years, right? That's how long it takes for the atoms in our body to decay. And the half-life of the human body is 40 to 50 years. That's the human body's atoms half-life, or what we call Middle Ages. That was very basic, but hopefully you get it. Hopefully you follow. Hopefully you understand what I just said, because my mouth does not. What Stephanie discovered in her research is that the half-life of polonium, why is that hard for me? Polonium seemed to depend on the type of metal that the element was placed on. Now, polonium has a relatively short half-life. Its full life is about 2.5 years, so its half-life is 139, 140 days. Finding that the type of metal depended on how fast it decayed got her thinking. If the alpha rays, which come from the decay of the heaviest radioactive element, which include polonium, uranium, and radium, from the polonium element possibly had transferred some atoms of the metal into the radioactive isotopes of the polonium. Still with me? All right. This discovery led to what is now widely thought to be the first example of artificial radioactivity. Still with me? Awesome, because my head hurt so much trying to decipher chemistry. Her research of alpha rays led her to formulate methods to measure alpha decay, which is a type of radioactive decay. And from this work, it led her to believe that radioactive isotopes could be formed from atoms as the result of exposure to polonium's alpha rays. I am smart. She got her Ph.D. from the Radium Institute and published her thesis in 1924 titled Research on the Polonium Constant and on the Penetration of Radioactive Substances into Metals. In 1925, she got a job working at the Paris Observatory, where during this time, being the researcher all the way she was, she dedicated time to investigate the possibility of sunlight-inducing radioactivity with French astronomer Henry Alexander Deslandres. When she left the Paris Observatory in 1930, she went back to Romania and began teaching at the University of Bucharest. Here, she did experiments researching artificial rain, then went to Algeria to test her findings, and while there went why not? And studied the link between rainfall and earthquakes, becoming the first to find that there is sometimes a significant increase in radioactivity at the epicenter, leading to an earthquake. Because why not have that pressing question and want to find that out? Because why not? Because I'm a scientist. Y'all people ask the most unique questions. Now this, it's annoying. Remember her findings with radioactive isotopes, alpha rays, and basically discovered artificial radioactivity? Well, her discovery inspired Irene Joliot-Curie, the daughter of Perry and Mary Curie, and her husband, Frederick, to do some research and then win the Nobel Prize in 1935 for their discovery of artificial radioactivity. Now, everything shows that Stephanie was the first to make that discovery. In fact, Stephanie said that she was upset at the fact that Irene used a large part of Stephanie's observations about artificial radioactivity, and Irene didn't mention her. Stephanie publicly claimed that she was the first who discovered artificial radioactivity during her good decade in Paris, and gave her evidence by which of her, doctoral dissertation that was published more than 10 years ago. Now, to Mary's credit, she did make a statement about Stephanie's contribution to the discovery, saying, quote, "It was a Romanian, Miss Mărăcineanu, who a few years ago was probably the first one to observe that non-radioactive elements could be made radioactive under certain conditions, meaning they emit radiation similar to the type which until now has only been observed for the few radioactive elements." End quote. Probably. Okay. How about totally? But retribution would happen for Stephanie in the form of the Romanian Academy of Sciences. On November 29, 1935, Nicolae Vasculescu-Carpin gave a lecture at the Romanian Academy of Sciences on artificial radioactivity and the Romanians' work in the field. And this had clear references to Stephanie's work. And may I say, this was after Irene won her Pulitzer Prize. On June 24, 1936, Stephanie sent a letter to the Academy stating she didn't want to contest the Nobel Prize, but she did ask to at least be acknowledged for her role in the discovery, because, she was kind of the first one. She even said that she was the first one to discover the phenomenon in 1924, and though Irene used the same method as her, the only difference, and this is ridiculously stupid that this is how Irene won the freaking prize. Stephanie placed the metallic foil under the polonium, whereas Irene put it on top. Polonium. Not, but you get the point. Polonium, metallic foil. It's a tissue. Let's keep up. Polonium, foil. Stephanie, foil. Under, polonium. Then wongs happened. Ooh, discovery. Irene, polonium, metallic foil. Wongs went that way. That was the difference. She just put the wongs going that way instead of that way. Freaking can't. She also noted that Irene promised Stephanie that she would be credited on her paper, but of course she didn't. Her request was granted on December 21st, 1937. She was elected as a corresponding member of the Romanian Academy of Sciences, Physics section. Later that month, she was named Director of Research by the Academy, and by 1941, she was promoted to Associate Professor. Now, all this is, of course, amazing, and she deserves being associate professor at this academy. However, in her lifetime, she was never recognized globally for her discovery. She remained in Romania for the rest of her days, and by 1942, Ștefania was mandatorily retired when she turned 60. After her retirement, she lived the remaining of her days by volunteering at a local hospital and published several research articles. Ștefania Mărăcineanu died on August 15, 1944 of cancer thought to be due to radiation exposure at the age of 62. She is possibly buried in Bellu Cemetery in Bucharest, but we just don't know. Her radiation exposure is thought to be due to her groundbreaking work and experiments with polonium and radiation because, unlike today, very little was known about the extreme dangers of working with radiation. And just to show how much of an injustice the recognition for her work is, in 2013, Romania did a stamp of her. Sweet, I want to be a stamp. However, her name and date is correct, but the photograph used is of Marie Curie. I did the research. Look at that. That is Marie Curie on Ștefania Mărăcineanu's stamp of a picture of her, but that's not her. That's Marie Curie. Come on, people. You can't even get the photo correct. Now, one thing I asked, and I hope you all ask with these videos, is how in the world is she unknown? Or at the very least, how did I not know about her incredible work? Well, when it comes to Ștefania, it's actually pretty simple and really petty. As with any field, there was a lot of competition among the scientists at the Institute of Radium, and as to no surprise to anyone, Murray's daughter Irene was given special treatment because she's the daughter of the director. And apparently, Ștefania was discriminated against because she was a foreigner and not being part of the Curie family. Don't know how that last one works, but whatever. Oh, and since Irene married a Frenchman researcher, that was apparently why she got special treatment. I don't know. And according to some sources, Marie became very jealous and upset that most of the groundbreaking discoveries in the field of radioactivity were being found by others and not by those of her family. As if groundbreaking discoveries should only be found by members of her blood. I had no idea Marie Curie was kind of a bitch. My husband and I discovered radioactivity. Only members of this blood should be allowed to discover groundbreaking things. Talk about freaking ego. It is also speculated that when Irene published her discovery of the artificial radiation, she couldn't even explain it properly. And of course, as we know, when she got the prize, she didn't mention Ștefania, even though she did all of the work. You know what this feels like and why I'm getting upset? This is like every group project in school ever. You all know what I'm talking about. But apparently, a few days after the Nobel Awards, a professor published an article called Radioactivity and presented Ștefania's research, not Irene's. And of course, that one dude did that presentation of it and did Ștefania's research and not Irene's research, so haha to you. In 2022, Google did a doodle of her for her 140th birthday. Whether Ștefania's name was deliberately omitted from history because of jealousy and a little bit of pettiness, or simply lost to history, Ștefania's name should be as well known as Marie's name because without her discovery, we wouldn't have the modern techniques to treat the various types of life's biggest bastard, cancer. Oh, and while I was doing research of polonium, whatever it is, did you know that polonium is the poison that killed that Russian defector Alexander, whatever his last name is, in 2006? Crazy things you find out when you Google something. There you have it, people. The story of Ștefania Mărăcineanu. It is mainly through her that we know how artificial radioactivity works to help cancer. That's why I have this channel, because I had no idea about her. She's just as awesome of finding out how to fight cancer as Marie Curie is. Astounding that she is obscured because Marie was basically jealous of her. Crazy. And the fact that they messed up the picture on her freaking stamp. It's a stamp. I don't know why that upsets me so much. If you learned something today, and I sure hope you did, please like, share, and subscribe to this channel. And while you're down there, please leave a friendly comment. I will be back next week with another video for the last week of Women's History Month. And this next one is going to be fun. But until then, don't be well behaved. You just might make herstory. See you next time, guys.